Here we go. We have a question, minimum jumps. So you have given a array of non-negative integer where each element represents the maximum length of the jump that can be made forward from that element. This means that ARR I, ith element is x, then we can jump any distance y such that y is less than or equal to x. And we need to find the minimum number of jumps to reach the end of the array starting from the first element. If the element is 0, then it means you cannot move through that element, and we need to return -1 if you cannot reach the end of the array. So we have a sample test case. Initially we have 1, so we start from this value and we can jump at max this, and we are at this location. We can jump at max 3 steps, so 1, 2 and 3. Here at max we can take 9 steps, so 1, 2, 3, 4, 5, 6. So 6 will work and we reach the ending element. So minimum number of jumps required is 3. We need to return that. So let's build the approach. Suppose we have this test case. So we are standing here and standing at here, we can jump at max 5 steps. We can take at max 5 steps. So we can jump till here. Although we can stop at any given position, but at max we can jump till this value. So let's take if let's take a case. If I want to stop here, so I take a jump here and starting, and we are standing at this value. So we stop at this value. So if we stop at this value, at max we can jump 3, so we can reach this value. Or if we stop here, at max we can jump from this value is 3, so 1, 2, 3. So at max we can jump here. If we stop here, so if we stop here, we can jump one value, we can take one step. Or if we stop here, we can jump 4. So 1, 2, 3, 4. 1, 2, 3, 4. We can reach the last value. So we have two cases. So if we are here, we can at max jump, we can at max take 5 steps. So if we stop here, so let's take stop jump, a variable stop jump. If you stop here, so at max you can jump, you can take index plus 2, so you can reach this value. If we stop here, or if we stop this value, so index plus 3, we can reach this value. So we take the maximum value from with this, so it will give us 3. We can reach 3. If we stop at this value, so we can reach 5, so maximum value is 5. If we stop at this value, the maximum jump we can make is 4. If you stop here, the maximum we can make is 8. And if you stop here, the maximum we can make is 7. So 8 is the maximum answer. So if I reach this value, it means if I reach this value, then from this value we can further jump and we can reach the 8th index. So we can go to 8th index. So now our maximum becomes 8, because although we took that we reach this index, but this index will not give us the maximum jump. This index will give us the maximum jump. So we don't need to require jump till the fifth index, till the maximum index. We can jump to this value, so this will give us the maximum, so we reach the last value. So our maximum answer is 8. Now we are standing mm, now we are standing here on fifth and on fifth. So from here we can reach eighth by taking one jump more, by taking one jump more. So first jump we have done till this. Now we have reached the maximum jump. Now we need to increment our jump value, so we need to require one more jump. So if we require to do one more jump, our maximum index we can reach is 8. So we will find it. So maximum we can jump is here. If I stop and make a jump from this index, if I if I stop and make a jump from this index, so it will give us 6 plus 3 is equal to 9. If I stop and make a jump from this index, so it will give us 10. If I stop and make a jump from this index, it will give us 10. The maximum answer we can have is 10. So now we have reached the index, but from this index we does not require to jump further. Why? Because this is the last index and we want to reach the last index itself. We don't require to jump further. So the maximum jump we require is 2. One to reach this value and one to reach this value. So that's how we tackle this question. Let me give you one another test case. So 0, 1, 2. So our maximum value starting is 0 and stop and jump value is 0 and jump value is 0. We need to find out. So this we have index is equal to 0, so we have starting value as 2. So we need to first find out, is this index possible. In this case the index is possible. uh, why I'm saying that index is possible, so I will give you one other test case so you will get a clear picture. In this case we start from this value, so we have reached the maximum index is 0, so we have reached the maximum index. So from this value we can jump to 2, so we increment our value to 2 and we also need to increment our jump value. So starting from this value we need to jump 2. Now we can jump to this value. If I stop and make a jump from this value, so it will give us 3. If I stop and make a jump to this value, it will give us 4. Now we reach this value. We have reached our maximum distance. This is the maximum distance. The index is the maximum distance. So from this index, this is the maximum jump that we can make. From this index itself, we need to make further jumps. But this is the last index, so we does not require to jump further. The maximum jump require is 1. So the minimum answer, the minimum jumps is 1 in this case. So that's about it. Let me give you another test case. Suppose we have this test case. So maximum jump we can have is 5 starting from this value, and jump variable is 1, and stop jump is initially 0, or we can say 5 in this case. So maximum jump we can make is 5. So the maximum jump we can make is 5. If I stop and make a jump from this value, answer is 5 itself. If I stop and make a jump from this value, it is 5. Here it is also 5 and here it is also 5. Now we have reached the maximum jump. This is the index and we have reached the maximum jump. So starting from this value, we can make a maximum jump till 5. So we need to do another jump. So we need to do the jump till 5. So the maximum, so if I in this given range, if I stop on any given index and make a jump from that index onwards, so this stop jump will provide the answer. So stop jumps says that we can jump till 5. So we need to do another jump. We increment our value and our maximum value is 5. Now we are standing this value in this index, and maximum jump we can make is 5. So 5 is the index itself. So we have another index. So this index, its index is 6. So this is 6 index. The ith index is greater than maximum value, means this ith index reaching till the ith index is not possible. Reaching till ith index is not possible. So in that case we return -1. Same goes for this test case. If I have these values, our maximum value is 0, jump is 0, stop jump is 0. If I stop at this particular index and make a jump, so it will give us 0. Now this is the maximum jump that we can make. This is the maximum jump, so we need to reinitialize our maximum jump. So our maximum jump we can make is a stop and jump. So if I stop and make a jump, it will give us 0 and we increment our jump. So we jump from this value, and standing from this value, if we make a jump, we have reached the index itself. So if I am here, so this ith index is greater than maximum, means this ith index is not possible. Reaching the ith index is not possible. So that's why we have to return -1. So that's how we tackle this question. Let's code this. We have a variable jumps, a maximum jump that we can make, and a stop jump. If I stop and make a jump, and n, so we need to iterate. So we need to find the stop and jump. So if I stop the ith index and jump from the ith index, so this is the answer. We need to find the maximum value in the stop jumps. So if the ith index is the maximum, this current index is the maximum index that we can jump, so we need to do another jump. So another jump, the maximum value of another jump is present in stop jump. So this is the last index. So before this we have a edge case. If this is the last index, we don't need to jump further, as I have discussed in test case 2, 2 and 2. If this is the last index, we don't need to jump, we just break out of this for loop. Else we need to do another jump, and we can jump till stop jump, because we stop at particular index, and from that particular index we make another jump. In this we so this is the condition in the if case. So else we cannot reach this particular index, this I is greater than maximum jump. So in that particular case we need to return -1, else we return the jumps. So let's give it a try. The code is given in the description box. If you guys have any doubt related to this solution, feel free to ask in the comment section. Give this video a thumbs up for motivate me, and thank you all for watching.